What's going on, people? This might be something we put on YouTube if it goes well, so I'm going to give people a few minutes to show up before we start doing things. What's up, people? It'll probably go on YouTube unless it goes poorly, and then we won't put it on YouTube. We'll see. Do I cover my webcam? It has an automatic lid that I can close and open or leave halfway accidentally. What does that look like? Yeah, that's great. I can do this. This could be our special stream that we do. How do you handle terrain collision? It depends on how your terrain is stored and what kinds of things you need to collide with it and what the results of the collision need to be. Can you disconnect the microphone yet? Well, the microphone's got a mute button on it. So if I press the mute button, which is why hopefully I leave the mute button off. You know what I'm saying? But then if I eat some breakfast cereal, then I might press the mute button. So how do you handle tessellation terrain collision? Now this question makes even less sense. Like, is this a randomly generated question? Like, what are you trying to do? What are you trying to do? All right, I'm going to warm up some tea, and when that is done, we shall start. Trying to get you're creating terrain map based on a height map in Metal. Wait, Metal is a rendering API. So hopefully you have a representation of your height map that is not in Metal. Like what? You're trying to get the correct height for your character. So you mean you're standing somewhere, like you're trying to walk around the terrain and you want to put the camera at the right height above the terrain. Is that the actual question? Because that's pretty easy. I mean, depending. But it kind of depends. So often terrain, when people say terrain, they mean like a height field, which is a simplified sort of 2D grid with height values. And in a case like that, well, it even depends on how it works. If it's a regular grid, then you can find the XY coordinate of the player. Well, you just look at the XY coordinate of the player, right? And then you find which triangle of the grid that's on. So that, it's very easy for a regular grid to go to the square. And then depending on, there's different ways that you might subdivide each square into two triangles, and you figure out which triangle, and then you find the height in that particular triangle, right? Now, it might not be a regular grid, but it might still be 2D, in which case, well, a quick and dirty thing to do that's not the fastest might be to just raycast against it if you have a fast way to do that. You just put the ray up from higher than you would expect the player ever to get and raycast downward, right? And that gives you the point, and then you add a z value for how tall you want the player to be. That's not necessarily robust in the player movement physics sense, right? If you want to robustly have someone walking around something like that, then you probably want to know where they were last frame and track the motion across the manifold, right? But it all depends. It depends on what your terrain is made out of, right? Some terrains might just be general meshes, right? They might have overhangs and whatever. So today's topic is we're going to do some interesting things in metaprogramming. We're going to start in 2 minutes or something, as soon as I can put hot tea into Winnie the Pooh. I'm glad you enjoy the streams. Okay. post-tessellation vertex function alters the vertex based on your input variables. But there seems to be some interpolation that I'm having a hard time accounting for. Well, that's the problem then. I mean, you need, if you're using interpolation or, tessellation on the GPU, that has to match the CPU or you have a bug, right? So fix that. The problem isn't, the problem isn't the question you asked. The problem is that problem. Did we do cube map shadows? Not yet. I want to do that on stream. It's just I've had a lot of different things to work on, so I haven't gotten to that yet. I'm glad you enjoy the videos and the talks. Do I also code? Yeah. Shroud's a little bit better than me at shooters, so I don't think that I would ever be able to take over his situation. Although it's been really funny watching high-end streamers who are very good at shooters like play the new Call of Duty and just they get killed left and right like nonstop. It's like that's just how the game is, man. That's funny. Where is the talk tomorrow? It was today. Talk was today. It is not publicly available, but I will give a revised version of it that'll be live streamed later on. You guys will get the better version, the more rehearsed version. And it'll just be like an overview or an update on programming language features and why the language is the way it is. Which some people have been asking for. Like they say, hey, there's just so many YouTube videos. Like what can I do to get like a small, compact summary overview thing? So that's what that'll be. There's like, at this point, 3 talks that I need to do and record, and I want to figure out, I want to find a venue where I can do that. I don't just want to do it from home or the office, but I want to like make maybe a little bit of an event out of it, invite people over. So I'm looking into that. How do you reference assets from your code? We tend to use short names. So like, you might use the name bricks to refer to a brick texture, and you don't know exactly where it's stored or what the file suffix is or what type it is. That's how we tend to do it. To Mason's Chapel? Maybe. I don't know. I don't want to get anyone killed. Am I going to drop by Handmade Seattle? I'm still not sure. I've just been in a very tired, I've done a lot of talks, I've done a lot of traveling. I kind of don't want to go anywhere. I'm already going somewhere like in a week, and Handmade's in like 2 weeks. We'll see. We'll see if I get a wild hair to go to Seattle or not. All right. In another minute or so, the tea will be steeped. I don't want to, I don't want to start talking for real before the tea is done steeping, because otherwise I'll forget about it and Winnie the Pooh will be sad. Any other questions? Any on-topic questions before we get officially started? How do we resolve the short name to the actual asset? Well, when we start up, the answer is a little bit different if you're talking about the final shipping game or if you're talking about like during development. But either way, right now, when we start up, we say, what are all the potential assets, right? In the final shipping game, that would be because we loaded a specific package and looked at the index, and that package is the only place we get the assets from. During development, we want to be a little more versatile and like allow the content people to add textures to the game and stuff while they're working. And so we do like a directory scan of, all subfolders of this certain place in the file tree. We get all the file names, and that's actually very fast. Believe it or not, as bad as computers and operating systems have gotten, you still can scan file names, at least in Windows, pretty fast. And so we get all those. And then we respond to file system events. So if somebody adds a new thing into that subfolder, then we know what it is. What is your advice for someone that wants to do indie dev but is too scared to risk it because money? My advice is, here's the thing. I get asked that question a lot, or related questions. And my advice is that if you're asking that question, you're kind of in a bad territory, honestly. Because you're in the space where lots of people ask that question, and obviously most of them don't end up doing it and succeeding. So you want to get out of where you're in mentally. Whatever that means, right? Whatever that means. How's the new macro system been to use in practice? It's been nice. There's a couple of bugs about namespacing. Like if I nest a lot of for loops really deep right now, there's some kind of bug about things not quite getting linked correctly that I need to debug. Maybe we'll do that on stream. But apart from that, it's been really good, and I dig it. ETA for compiler release. I have vowed to multiple people that we are going to do a closed beta before the end of the year, and we are sticking to that. You're an indie dev risking it in the next couple months. Any suggestions for how to market better? Best place to put money towards? When it comes to indie games, you can't spend money to market something that's unmarketable, right? Like your game has to already have some magic to it. And if that's true, you can use money to amplify that. But you can't use money to get people interested in something that people wouldn't be interested in. So you need to make sure that the thing that you're making has some punch to it. You should use Visual Studio Code for your coding files. Just a recommendation. Yeah, okay. Thank you for the recommendation. I will take that under advisement. What is the first? I think Hans Gruber said that in Die Hard, but I don't remember. I don't remember if that was a thing before that movie made that a phrase. All right. We've got our hot tea. We are pouring it out. We're pouring one out for Winnie the Pooh. I forgot to use the filter, so we got some leaf bits in there. That's okay, though. It's part of the tea experience. Did I learn from the people around me, or was it mostly learning on my own? It's a mixture. One of the best things you can do is to put yourself in an environment where you're surrounded by people who seem to know more than you and seem to be smarter than you. It might just be that they have more practical practice and are working harder than you. But when you've seen that, like if it's going to conferences or just being around school or some community, that is a very, very useful thing, right? But if you're in that environment and you do well, you'll eventually become that person to everybody else. And then you won't have that as a driver or stimulus anymore. And at that point, you really have to know how to self-motivate, or you'll stagnate. All right. All right, let's talk about some things. Today, I went and gave a talk at a company outside the games industry. It was a, let's say, a film industry company located here in the Bay Area. And that was cool because I usually just talk to game people or don't talk to anybody. So it was a good thing to go do. And the talk was, just an overview of technical features about the language. And for people who have been asking, will that talk be publicized? It won't. It wasn't recorded, but I'm going to do a beefed up, longer, and revised version of it that will be live streamed and recorded later on. So you'll get that speech. And basically, that'll be a summary of what is interesting and important about this programming language, because a lot of people ask for a summary like that. And they say, I don't want to watch your 172 hours of YouTube videos, especially because half of them are out of date because things have changed since then, which I sympathize with and understand. And so this will be a compressed overview, summary, like why is this interesting, and so forth. Okay, so we were having some conversations after the talk, and one place where the conversation went was, about other programming languages that have been successful and why they succeed. And someone was talking about Python and how, there's just lots of libraries to do really simple things in Python that you just want to use to get rolling quickly. And it's always interesting to me about, the tension between things that get you rolling quickly and that are also usable later in an efficient and robust and strong system versus things that get you rolling quickly that end up being a strong disadvantage later, for example, garbage collection, right? And so one thing that was mentioned was command line argument parsing, which I don't really program in Python, so I don't know how this goes. But he was like, hey, in Python, you can just have this declarative thing where you pass it to a routine and it parses all your arguments and you get it back in a nice form and all that stuff. So I was thinking about that and I was like, I wonder what I could do for argument parsing in this language that's natural, that we can do with metaprogramming, and that's still very strongly typed, still not error prone, and very useful to people. So I wanted to use that as an example today of, or use that as a test. Like, let's just do some metaprogramming. We haven't exactly done this kind of metaprogramming in a while, so we might hit compiler bugs. I might have to stop and work on the compiler to fix them, who knows? But I wanted to start with some command line parsing stuff. And then, so another thing that we talked about, and I don't know if we'll get to this today because there might be enough in the parsing, but we were also talking about the SOA versus AOS thing. And some people there were familiar with some of the earlier presentations I had done, and they were like, hey, what about that part of the language? Where's that going? And I explained to them the following thing, that the old version of SOA that I demoed, I felt like was a little too complicated in terms of how much complication it adds to the core semantics of the language, and just a little too specific in terms of like you couldn't quite use it as generally as I would have liked, and just a little too limiting still. And that's why I deprecated that. And of course, as people who follow these streams know, I've been saying for a while, yeah, I'm going to get back to that. We're going to do it a new way. And so the new way, I explained, part of it is that we can theoretically already do, although I haven't tried, is we could theoretically make a compile time function right now that says, here's a struct, make me an SOA version of this struct. And it could be AOSOA, right? Like, so 64 elements per block. Manufacture this struct for me and let me use it, and make an array operation so I could subscript that and get back the value, right? And the thing that I said was, the thing that's not quite figured out is then how do you use that along with general code that somebody else wrote that doesn't know about your struct, that just wants to use arrays and iterate over arrays, right? And I have a vague plan for that second thing. But the more I think about it, it was like, well, why don't I just do the first thing in the near future, and we'll at least have that part, and that'll get us closer, and we can just see if there's anything, sometimes you start working on something, and as it becomes more concrete, it gives you new ideas, right? So if the argument parsing goes well, then later this stream we'll do like an SOA struct manufacturer, right? And if it doesn't go well, we'll do that, later this week or something, right? So is there any questions or things that, given this knowledge, that people would want to see me do tonight? Question, is general purpose allocator necessary for reliable desktop software? For example, a general dynamic array requires a general purpose allocator. I know a small number of people who try to write software that never allocates, but for the most part, I think you do want a general heap allocator as a tool in your toolbox, but I think you want to use it sparingly. I don't think you want to use it a lot of the time, and a lot of the language features here that we've demoed before, for example, the temporary storage, are about both how do you increase efficiency, right? How do you reduce the penalty that you get for allocating things, but also how do you simplify it? How do you make it so you don't have to think about the lifetimes of values and things like that? And so temporary storage applies there. What specifically would you need in the language to support SOA more elegantly? Well, maybe we'll just start doing the thing and I'll talk about it then, because it's definitely, it's an involved subject with many subcategories to talk about. But it would make me feel good to make more progress there. Okay, but first we'll do something simple and just make sure our metaprogramming works well. So this here is the code for the command line arguments in the Sokoban game. And they're not that complicated right now, but maybe that's fine. Like you can set the language that you want to be in, right? So if you say dash language, the next argument is a string saying what language it should be, right? If you say dash size, the next arguments are 2 integers. And if those are set, then we set a variable that says window dimension is set and blah, 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 right? There's a note, and then these are all Booleans, okay? And so basically what I want to do is make a data-driven version of this. And it's going to be kind of magical, but not so magical that it's inefficient or that you don't want to use it. And here's what I'm going to do is the following thing. I'm going to say arguments, right, is a struct. And it's just going to have the fields that I want. So I'm going to say language is a string. I'm going to say size is an array of 2 int, right? Or we'll say x64 just to be specific, right? And then what were the other things? No vsync is going to be a bool, right? Or yeah, we'll do that. And windowed is false, and full screen is false, right? And then what we're going to do is we're going to make a function that just says parse arguments and pass it this, okay? And it's just going to do everything that does all of this and then put the values in this struct in the end, and then we just use them, right? Does that make sense to people? So I want to say the following thing. I want to say main, right? I mean, actually, let's put this in a separate program. Right now, I'm in the Sokoban program, but we'll make a separate program. I just want to say main args is parse arguments of arguments, right? We'll call it my arguments to reduce the amount of confusion, because we might call the module arguments when you pass it out. I want to say this, and then I want to say stuff like, I don't know, print args dot size 0, right? I want all this to work. Probably don't need both windowed and full screen. Well, okay. Maybe not. I think those, you're right, we don't really need both of those because they're mutually exclusive. I think the reason those are in, it's a little bit of an interesting question. The reason both of these are in here right now is because like during development, we set it so that we're windowed by default, but during release, we probably set it so that we're full screen by default, you know? And then you want an argument to go the other way, which is interesting because already that doesn't necessarily, like if you just have both of these, I can't just check one of these to know which one you set, right? However, one of the things maybe that we want to generate, so in addition to generating the code that does, or maybe we don't even generate that code, maybe we just look at the type info and do it, right? We probably want to generate a struct that says like something like this. this is again, see what I'm doing? Like for every one of these, see with this, we can have default values for all of these, but we don't know if the user actually passed that argument, right? But we could return as the second value a new type that we manufacture that has all these things for all 5 of these. And then we could tell if someone said dash windowed or dash full screen, right? And this would be something that we don't generate, that the system generates. So that sounds like a good test to me. A lot of Linux CLI parsers allow that so that you can override an alias that includes a Boolean parameter with the opposite option. Yeah, so a different thing that we could do is, for example, I mean, let's say we wanted to change, let's first say we wanted to change, like if we wanted to change this name to dimensions instead, we could put a note like name dimensions, right, or rename, right? Like, we want the external name to be this, but the internal name is still size. Or maybe we want both. Maybe we want people to be able to say dash size or dash dimensions, so we could say alias, right? Or maybe, like someone was saying, I'm not sure this is a good idea for right now because we want to think about what features, but we could say like windowed, right? And then we could say alias, maybe not full screen, right? And like this would say, well, this is the opposite of that. That's a special case just for Booleans, but programs, command line arguments seem to like Booleans a lot, right? So is my arguments the type of the returned args? Yes. So it would be returning us one of these and filling out the data based on the arguments. Sounds like an enum? Not if it's a Boolean, dude. Do the at notes deal with language constructs, or is it more of a plain text thing? Right now, everything after the at sign is a string. I want to make these structured later so that you can actually have struct instantiations and whatever here, but right now they're strings. Short argument names. No, you know, I'm not a big fan. Like, here's the thing. I like simplifying systems. I'm not a big fan of all the complexity that has crept into command line arguments, for example. Like they're just there's so many different things. There's like dash and then a bunch of single letter arguments in the old Unix style. Those have sort of been deprecated a lot of the time because nobody frickin' remembers what all those different letters mean, right? Except for a few privileged programs like LS or something. So people use dash and then a longer name usually now, except for backwards compatibility with things that had single letter arguments, then they use dash dash in a name. Or maybe they use dash in a name, but maybe they use plus in a name, but plus in a name means turn the feature off, whereas you would think that plus means turn it on, but the reason plus means turn it off is because minus means turn it on. And I don't even know, that's even just the beginning of all this like nuttiness that has crept in. It shouldn't be that complicated. It should be simple. And so I'm not going to do in this system everything that everybody does for command line arguments. I don't like that. I don't want that. I don't want to think about it. But we'll probably do some simple things, you know. No, I'm not joking, by the way. Yeah, someone says I'm actually not joking. That's literally true. Yes, it is literally true what I said about arguments. And again, that's only the beginning. Do we intend to support enum-typed arguments with Metaprogram? I think in the long term, yeah. I don't have a good example of that right now, but I don't see why not. Like if you have an enum with 7 different names, and then those are the things people could pass. There's windowed, full screen, and borderless modes. Maybe. Right now our full screen is borderless. We don't really support non-borderless full screen because it's too annoying and stupid on Windows. That is ridiculous complexity for something that barely matters. Yes, that is my opinion too. Again, like if computers are going to be sane and work better, we have to simplify them. And simplification has to happen at all levels, right? Everything has to get simplified. Command line arguments is a perfectly valid place to start simplifying. And so that's what I want to do. What's the thinking behind the isSet second return value? We'll get into that. Let's work on the main thing first, and then we'll do this second thing. Let's start doing some concrete code. So let's go here. I'm going to make a new thing called args, and we're going to start. Just by doing this, and actually, I'm just going to leave this up in this other buffer as a reference for like what we actually want to do. So we're going to develop all this in a separate, clean little program. But then in the end, we will convert the Sokoban game over to using this if all goes well. All right. So I'm going to say args is parse arguments of my arguments, right? And I want to say print args is whatever, right? And args. All right, let's put it lowercase because that's the variable. What is parse arguments? Well, we're going to start with something very easy. It's just a type that has to be known at compile time. It returns t. I'm going to say result is of type t, return result. So we're just returning the default value of this thing. Right? Seems easy. So, okay, just because today's a special day, let's start over a new shell so that we don't attempt to index a nil value all the time. I know that we don't want to get big heads about ourselves and think that our computers really work. All right, so I just did that. I just hit F7 and built Sokoban just so that I would have the compiler command in my buffer and I could delete. That's what happens when your build is so fast that you don't care. You could just do stuff like this. It's really great. Oh, whoops. I'm in the wrong folder. So we're going to go there and then do it, right? Oh, we don't have print because we didn't import. Import basic. All right, args. There we go. We don't actually print the values of arrays of integers right now. We just say the type. Maybe we should change that. It's just questionable because what happens when there's a lot? Actually, that's another thing we could do on a stream is I had a good idea for how to put print handlers in the context and stuff. And maybe this also is something that can go in the context. Like if you're going to print array elements, how many do you print before you say ... or something? You know what I mean? Attempt to index a 0 bagger. All right, anyway, so this is great. Like, we're almost done. It's just that we don't actually do anything yet. but we have a program that gets arguments. Okay, so now what? Well, let's get the command line arguments. And we're just going to be very slow about this at first. We're going to say for args, actually, let's do this. Because again, we want to manually increment the cursor because sometimes we want to skip it by more than one. And you can do that with a for loop. It's just a little dirty. Like if somebody reads a for loop, they don't expect you to be cursoring around randomly in the middle of the for loop, you know? Whereas if they see an index and you manually add to the index, then people know what to look for. So we're going to do this, and we're going to do this arg. And if arg sub 0 is not equal to this character. So we're looking for something with a dash, right? Well, what should we do? Should we just print things? Let's just say we're going to have a thing called report error. Argument whatever does not start with a dash. We'll not put a new line. That'll get added, right? And then cursor. And then break. Oh, we're going to want to know if things were successfully. We're going to return that as our first thing. So success and result is a T, right? So we're going to say success. I put the success first so that it's harder for people to ignore it. You could also use the must directive, but you know, whatever. It's good to make people think about the success argument or the success thing, right? So if no success, we just exit main, right? Otherwise, we print the args. Okay, so what is report error going to do? This is going to be part of the arg. So everything below this line is the main program, right? And let's put my arguments down there. And everything above this line is the module. This is like importing basic is honestly probably in both, so whatever. Actually, let's do it twice. So yeah, so report error. Format is a string. Args is any, right? And for now, we're just going to say log print parse arguments, comma, format, .r. We're just passing it on to log print. Question is, what is do we have a default logger? I actually don't remember. When we start up, default logger does nothing. Okay, so we're gonna set a logger first. Context.logger is my logger. We probably should write string the message. We'll worry about that later. Let's not rat hole on things. So we're going to make a thing called mylogger. So this is just going to say print ident message. Okay. So we probably already made a mistake where we don't compile. Let's just see. Return statement is missing argument result. Oh, because success. Return true result. This is return false result. Okay, great. Let's print success. All right. It'll be true because we're not, whoops, I compiled Sokoban again. Args. Okay, success is true. Args is this. Okay. Well, that's interesting because we at least went through this loop, except we didn't because there's no arguments, right? So let's try args-hello-sailor. Uh-oh. Oh, because we don't increment cursor. That's the danger to doing things this way. All right. There we go. Success is true. If we don't say dash in front of sailor, Success is false. We didn't, however, oh, we didn't say the, we have to set up our logger before we call parse arguments. That is some 4D chess for you right there. Okay. Argument 2 does not start with a dash. So that's good. How does it work when you want to make your own custom allocator? Let's not rat hole on that too much because we're talking about something totally different. But to make an allocator, you just make a function that takes all these frickin' arguments. And I want to simplify this back down to fewer arguments at some point. But that's what an allocator is. It's just a function that takes those things. OK. So this is great. Well, we're just going to do a simple linear check down the members. OK, so advance arg by 1, right? And then we're going to print looking for an argument name. This is just a print for our own edification right now, right? OK, so then if we run this with hello sailor, we're looking for an argument named hello, looking for an argument named sailor. This advance just skips the dash in the string, right? So that's good. OK. Now, for, we'll say info is type info of t if info dot, is it called tag? I forget. Let's see. Yeah, if info.type is not equal to type info tag.struct, then we're going to return false. Maybe this isn't even report error. This is like, oh, that's fine. Type passed to parse arguments is not a struct, right? So if you pass us like a freaking float or something, it's like, come on, bro. We need something to look up the names. It had better be a struct. OK. So let's just say, let's just put members into its own, right? So type info struct has this thing called members. We're just going to put that into a thing, right? And the reason I'm putting it into a separate variable is we might want to filter this later. Like, for example, if some of these members are like constant or something, let's actually do that. Incomplete, skip constant members, right? But for now, we're just going to say, actually, no, you know what? Here's what we're going to do. Members is an array of pointer to type info struct member. Members.allocator is temporary allocator, right? So we're using temporary storage. And we're just going to loop over and make the copy now, because we know we're going to want to ignore some struct members later, probably. So we're going to go for info. This info is one of these type info structs. Oh, for info.members. And I'm going to say array add members it, right? We're going to take this by pointer. OK. So we just made an array that has these members by pointer. All right. So now, for members, let's call it member, right? If it.name or member.name is not equal to arg continue. Let's say found is false, right? Found is true. If we didn't find it, report error, unknown argument. What's a good string for this? What do people say that's not totally communicationally deficient? Argument whatever is not valid, right? Let's put it in quotes, right? And that's going to be I just totally blanked. Cursor is the index and arg is the string. Okay. So now when we say hello sailor, it should say hello is invalid. And sailor is not valid. Let's say success is false, right? So we're going to return success. If we ever failed, we're going to say success is true, right? So there we go. So success is false. Let's go ahead, though. In the case where success is false, let's still go ahead and print out the struct, because if we parsed anything before... All right. So now, if we give it some arguments that it knows, it should be fine. So if I say dash language, dash window, dash size, that's all fine. But if I say dash hamburger, it'll complain about that. Isn't programming fun? Couldn't you pass the type passed? Couldn't you test the type passed at compile time with modify? Yes. I think we could also static assert it, except even though type info is known at compile time, I don't think constant expression evaluation knows that right now. So, but yes, we could check that at compile time. Let me make a note that we might be able to do that. Improvement, we could test this at compile time using modify. That is somebody who watched previous streams and knows how this stuff works. All right, we have 87 lines of code so far. So we've done 8.7 days of work in industry standard measurement. In your case, success is always false. Okay, now what? Well, we want to start handling these arguments. Okay, so first of all, let's note that I have violated many programming guidelines that people teach in school. Like, dude, this function already goes from line 3 to line 53. This is a 50-line function, and it doesn't really do that much yet. According to people in school that I've heard from, this should be at least 4 functions already. But we're not going to do that. "50 functions per maximum efficiency." My functions are all church numerals in terms of their call graphs. Okay. Let's handle strings. Strings should be very simple because the argument is already a string. Okay, so we look for the members. So if member dot type is equal to whatever. Let's using, I don't want to say type info tag, so we're going to say using type info tag. So we're just going to say struct here, and down here we could say case integer. Let's do string first, right? Case string, case I don't know. What are our types? Why don't I just look at the types, right? So we're going to do float. We're going to do bool. And we're going to do array later because we have an array. And maybe we'll do enum. And the rest of these like don't really make sense. Maybe we could do type almost, but I don't know. Anyway, so for now we're going to do string. But otherwise, all of these right now are, Emacs doesn't understand my switch statements. We're going to say report error unsupported. We're going to say argument is of name is of unsupported type whatever. Oh, we're not new lining. And then okay, so cursor name and member type, right? And so all of these we're going to have through on here. They're all going to fall through. Whoops, no, not that one. They're all going to fall through down there and print that, except string, right? Oh, also, actually, we will through that, and we'll say default case. OK, print a string. OK. And, you know, I feel good enough about the argument names that we're going to delete that print, right? OK. So let's delete the hamburger. OK. Language, windowed size. OK. I feel a little bit disappointed that we didn't hit this error. Why didn't we? Oh, so hold on. Success has to be false in this case. Did we not recompile? I think we didn't recompile. We didn't recompile. Remember to recompile, kids. Undeclared identifier name. Well, it's let's use member.name. We could also use arg. We'll use arg. It's a little cleaner in some sense. OK. All right. That's. Oh, we said args without arguments, so of course it succeeded. Args, language, windowed size. OK. Language is a string. Great. Windowed is of unsupported type bool. Size is of unsupported type array. Any questions so far? Did I advance cursor? I do down here, right? So this is just looking up the individual members. Yeah. Let me move this found equals true up to here, because we decide that we found it as soon as that. So let's just do that. We do. This is going to be our big handler. Honestly, we'll probably factor this into another function eventually. It's just right now it's not quite enough of a thing. And then we go, right? So any questions about what's been done so far? Misspelled unsupport. Wait, really? Unsupported. Don't you guys aren't down with the new spelling? The new spelling is that unsupported is a thing. Is report error just print? Report error right now is basically it's log print, which just puts this. We're not working that hard. We're not working that hard here. It's just, you know, maybe sometime later we'll do something more sophisticated here. In a perfect universe, this code would pre-build some structure that doesn't need to reiterate over the entire struct members every argument, right? Yeah, maybe. I mean, you could make a hash table out of all the member names and whatnot. Who knows? You certainly could. Right now, I guess we don't need to do that. Like, I had assumed that when we sit down, we were going to write something that generates code, but right now we're not generating code, we're just looking at type info. However, I think we are going to want to generate code to make that struct that tells us whether arguments were received. Although, maybe, do we want to do that way, or do we just, I don't know. It's unclear. Maybe we'll do that just to do it, just to be flashy. But let's actually do the meat of our thing, just to handle this. So here I'm going to say, if it's a string, then ensure get next argument cursor. This might fail. If we run out of arguments, this will fail, right? And we'll print some error, right? And we're going to modify cursor, right? So let's call it value, right? And then we're going to say, we need to make this. So we're going to copy the string, right? Copy is copy string of value. And then we're going to stuff it into the slot. Slot is going to be, we should maybe make a more general thing for this, but cast a pointer to string. Oh, we need to, okay. We got to test relative pointer size. We're not going to handle relative pointers right now in strings. Okay, so we want to copy the string. We want to get the offset of, let's just pre-compute the offset up there. So let's just do this. We're just going to say that is going to be a copy string of value, whatever. We're just going to put it all there. What is offset? So offset is going to be whatever the base pointer is, right? Cast a pointer to U8 of the address of result, right? So we're casting to pointer U8. We actually, I don't think we need those parens. We're casting to pointer to U8 so that our math will go 1 in either way. We could also cast to void pointer if we wanted to do that, but we're not. So we're casting to pointer to U8 of the address of result plus, let's do this for clarity. We don't need this, but just for clarity so that people know. Plus the member, oh wait, it's got to be down here. Member dot off, is it called offset in bytes? Okay, so we have this offset. It's actually not offset. Let's call it slot because it's not a number, except in the way that pointers are numbers. So there we go. Let's just see what happens. Oh, we didn't do get next argument. So what happens is we are fired because we forgot to write this enterprise level code. Get next argument. It takes some stuff. It returns a string. Okay, we're going to say, oh, we want to pass the arguments. What is that called? Args. So get next argument. Args is, this is the kind of thing that you might do in a language with closures just by passing a closure with all these things, but it's not really worth it for something like this. I like the clarity of being very explicit. So args is an array of string. Arg is a string. We could use the cursor to know the argument name, but if there's like aliases and stuff, who knows? We're going to pass this explicitly just to be cursor result is a pointer to int, right? And success is a pointer to bool. You must dress for success. Okay, so we're going to get the next argument. And we're going to say cursor is the dereference of cursor result. If cursor is greater than or equal to args.count minus 1, because we need room to increment it, we're going to say report error we're going to need a better, for things that have multiple argument requirements, we're going to need a better message. But for now, we're just going to say argument or option. Let's call it option. Maybe I should say option everywhere, like for command line options, or maybe they're not optional. Who knows? We're going to say option whatever requires an argument after word. What should I say there? What should that string say, right? No check-in, be consistent about option versus argument. Like, you know what I mean? Like to arguments, the things after them are arguments, but the argument is an argument. Who knows? Who knows? Anyway, so we'll put false into success, right? And return the empty string. Else, actually, I actually want to know, so it's useful as a shorthand just to set the success for this whole function, but I also might want to know for this particular argument, did we fail, right? Because maybe we don't want to overwrite whatever the default value was in the struct, which this function doesn't know. You know what I'm saying? Okay, so otherwise, cursor plus equals 1. We'll put that back in cursor result. And return true, comma. Oh, wait, dude. We already incremented cursor. Oh, no, we didn't increment cursor. Okay, good. Return true, comma, args sub cursor, right? Okay, so get next argument. It's a little more. We're going to say success and value, and we're going to say if success with 2 S's. Okay, who knows? How many mistakes did we make? At least one. Oh, geez. This is the fun part in our parsing is, right now, if we do that, we think that equal is a binary, whatever. Don't want to explain it. That's the one funny, annoying thing in the syntax right now. All right. Oh, yeah, success is used before its declaration because these are both called success. Let's call this string success. Okay. All right. Language equals dash windowed. Yeah. So it's up in the air about whether, like, you could imagine adding adding an option that says, like, look, this argument is never going to start with a dash. So if it starts with a dash, then someone made a mistake, and we should flag that, right? Let's say improvement. Have an option that says that if we see a string that starts dash, it is a mistake, question mark. Because we want this to be very friendly and not to be error prone and to catch common problems, right? And catch problems that you wouldn't necessarily bother to catch if you wrote argument parsing yourself every time. Okay, so here we might say dash language, language, English. There we go. And now it's in the slot. So the magic is already working. If you returned false in the if statement, what was the purpose of the else statement? No purpose, really. Sometimes I flatten those things out, and other times I don't. Yes, you certainly, in this case, you could get rid of the else here. And sometimes I do that. Just in this case, I'm not totally feeling it. Okay, did people have suggestions for how I should phrase this? argv machine says no. Missing value for argument. Okay. That's okay. I'm satisfied with that for now. Okay, so we can definitely do this, right? We could also go dash language. So now here's the thing. Whoops, we didn't recompile. We probably also want to detect when you pass something multiple times. All right, missing the value for argument language. That's fine. Okay. Great. Let's make some incompletes at the top. Incomplete. Detect multiples of the same argument unless they are permitted. I don't know exactly why you would permit that in this current structure, but yeah. We'll put that one there. Okay, relative pointer size I forgot to do. If member.relative pointer size improvement statically forbid this. Let's do that actually. Let's make that a disqualifier. So here when we do these members, we're going to say if there's a relative pointer size, we will say report error member has a relative pointer. This is not permitted. Now the problem is, okay, member doesn't have relative pointer size. I'm on crack right now, but let me finish this string. Member.name. So if it's a string, so that's how we get the relative pointer size. We want it, the type info string. Whoops. Whoops. Type, buddy. All right. So I keep wanting to run args with like nothing. Okay. So now the reason I'm doing that is just because, like, we're heap allocating stuff. It doesn't really make sense to use relative pointers in the first place. But if I did this, we're forbidding that. So here, oh, member language is a relative pointer. This is not permitted. But we're not exiting, and then we crash because we tried to stuff the thing. So we'll allow for a failure up here. We'll skip this particular member, and then we'll just say if not success, return false. And again, we could detect this at compile time. But for now, we detect it only at runtime. Whoops, let's recompile. Whoops, and what? Oh, return false result. Okay. Member language has a relative pointer. This is not permitted. Great. So let's get rid of that. Great. So we just want to do some other types. I kind of feel like we should at this point have a relatively general string to type function. Like we should have a function that takes a type and a string and returns a value of that type, but we don't, I don't think. Uh-oh, the tea might be oversteeped, people. We've been leaving it. Let's see what happens. I mean, it was the second steeping, but still. Anyway, I don't want to rat hole too deep on this tonight, on weird stuff. The main thing we definitely want to do is support all of these. And arrays is going to be, of course, the interesting one. Although, again, arrays is a little bit complex because you want to have arrays of any of the type that we support, right? And so, yeah. Anyway. We'll deal with that bridge when we come to it. Let's actually make a single integer and a float. Let's say number is S64, and we're going to say float. Let's say X is a float and Y is a float 64. Other number is S32. Let's call it I'm pretty sure that I have code somewhere that does this. So maybe we're going to factor that out and provide it more generally. I'm pretty sure I do that in Sokoban or something. How easy has it been to implement this so far? It's been pretty easy. We've been sailing along so far. For bool, is it going to be enough for it to be on the command line, or will it need to be -windowed true? I think for now, we're just going to set it to true if you provide that argument. And then we might have an option that you could put on the struct that says, actually, we want you to write true or false or something like that. You know what I mean? But I think the most common use of bools in command line arguments, let's just do that right now. Let's make sure I didn't screw something up there. OK. Let's put bool, because bool is not hard. So for bool, we say we just set it to true. All right. So there we go. We've got all our new members and stuff. Windowed is true. Full screen is false because we didn't say full screen. Oh, did I? So incomplete did generate information for which arguments were actually supplied in some way that's easy to deal with. Should it set whatever the opposite of default is? I don't think so. I mean, again, it's quite possible that something like that is the right thing to do. But my policy whenever I'm doing the first version is to not do anything weird. Is just get the basics in and make it work, and then we'll see, right? So let's comment out the array member right now, right? Just because we don't handle it yet. Incomplete handle arrays. Okay. So we're going to do this. Whoops. So we're not complaining about arrays. Size, oh, we don't have a size. There we go. Okay, so now we're automatically getting language. We're automatically getting windowed, right? And so for people who have tuned in recently, what we're doing is we're writing some library code to make argument parsing nice so that you don't actually have to parse anything, right? So what happens is you in your program just make some struct of what are the values that we want to get from the command line. And then you just pass it to the magical parse arguments. And so this is the user code, right? And this is like the library code, all this stuff up here. That is what we're doing. If you pass an explicit value for the bool now, it would fail. Yes, because we haven't said that Booleans take any more values after. So if I say dash windowed true, it's going to say, I don't know what true is. Well, you know, it doesn't start with a dash. It doesn't say literally, I don't know what true is. Okay. So for numbers, let's do integer. I'm trying to remember. I have this put function in Sokoban. That's polymorphic. It's in serialize. Let's go look at that. Oh, this puts into a string builder. It does a memcopy. That's not really what I want. I guess this used to do. Yeah. Okay, let's not do that. Let's see. I know Ignacio has some overloads for maximum and minimum values. So kind of what we want to do is we want to range check the input value against the potential range that the variable can hold, right? So if you say it's signed 8 bits and you pass 129, we want to say that that is too big, right? And I know I've done that before, so I have that code somewhere, but Ignacio at least has the max and min. Like if I go to oh, it's maybe math? So yeah, he has this thing that generates a bunch of procedures for different things, which we could call this, and this just handles all of these. So we could do that. And then that handles the signed versus unsigned part of it. Except that usually I get lazy. We'll not worry about U64. Usually I get lazy and read things as signed 64. And U64 has a different range. Let me just see. Okay, so I have usually like an as S64, integer as S64. Right, so I have this. Oh, that's to read. Okay, that's to go the other way. Oh, I have write integer. Yes, okay. Write integer as S64. Okay, so this is basically a really dumb function where I pass an S64 and do all this. I could clean this up. I'm just going to copy this at first, but maybe we break it into a signed function and an unsigned function, right? And we call it with the right thing either way. Let's do this. So we're going to go back to our args program. Right, we're going to have, we take a pointer and a value. Okay. Oh, and I don't overflow check here. So, okay, let's do this one step at a time. Put that up there. That's probably the next one we're going to do. We're starting to rack up the incompletes, which is a little scary. Okay. So min, we're going to say low is min of value, high is max of value, right? I don't quite like these because sometimes I just want a variable called min. I want to say min, whatever, but this is what we have to work with. So, oh wait, it's of type, min type of okay. Right. So if value is less than or equal to low, report error, value is out of range for argument whatever. We're going to pass the name, value of argument whatever is too low. The value must be between whatever and whatever. Right, name, this is a string. Why did I not put that? And then low, high, right? And then we're gonna go bool about whether we changed it or not. Return false. Not if equal to low though, just if it's less than low. If value is greater than high, is too high. Okay. Then otherwise, we're going to do this stuff and we're going to return true. Right? And we're going to break this stuff up, again, like I said, into probably signed and unsigned, or maybe we'll make this polymorphic and just call it with either one. The trick is, if it's unsigned, we probably want to parse as U64, if I even have that. Anyway, so now, how do I get an integer? To integer. All right, let's go look at that. To integer. Who defines toInteger? It's in string? Are you... Okay. Whatever. So that seems a little too basic to be in string, but... Oh, string to int. Oh, that's also here. So this parses a thing of an arbitrary base, but we could bake the base. This was using A to I. Oh, was using. I guess it isn't anymore. Yeah, this is our own thing. What? Why? Okay, so we assert that base is 10 or 16 for now. I know I did something somewhere that does base like at least like 46 or whatever. I don't know. That's so weird. I did that in a demo program, but I guess that didn't make its way here. Okay, so we're just going to use toInteger for now, and we're going to put incomplete vet toInteger to make it better, right? This returns an int, which is signed. So again, very large ints, this is not going to work for. So we're going to have to do something. We'll see. Just get it done, and then we'll see. So, okay. Let's go back to this part. Remember this? Remember the thing we're actually trying to do? So here we're going to say int success is, we're actually going to go, going to do this same thing. String value is get next argument, right? If we had a next argument, we're going to say, we're going to say, well, we already have the slot, right? So we're going to say write integer as S64, the name, the type info, right? That it wants it to be casted to the right thing. So we're going to make that. We're going to pass the pointer, which is slot, and we're going to pass the value, which is going to be int value, and we don't have most of these yet. Okay, so we're not going to use int success either yet, but let's just get it. All right, so what's TII? It's just casting to type info integer of member.type. No problem. Slot, we have int value is, what did we say this was? toInteger, let's make this int success, is toInteger of the next string value, right? If we didn't get int success, then we say report error value of argument whatever was not an integer. It was whatever, right? So arg and string value success. Oh, this is if not int success, right? Success is false, right? Else we do this. And we don't, let's call this write success, whatever. We've got all, we're checking for our mistakes. So we do write success. Where even am I here? Oh, this is tests. Why are we looking at tests? So toInteger, this is a bake of string to int. It returns result, success, and remainder. We're going to ignore remainder for now, although actually, okay, if remainder warning, junk on the end of the value for argument whatever. Let's put the number in as well. Like, you know, I don't know. We should probably standardize this. Junk on the end of the value for argument whatever, period, comma, right? Count, arg, and so arg is the name, right? And then string value, but remainder is going to be here. Okay, so remainder. We're not going to set success to false in that case, I guess. We're just going to say it. Okay. How many mistakes did we make? Probably a lot. Mismatch. Ugh. Wait, what? Did I use these wrong? Max takes a type. Okay. If value is less than low. Why is low a type? That's weird. I've never used these functions before. Let me just see how it uses them. Am I spacing on something? Max U8, yeah. I mean, he seems to use them just like that. Let me just say T is type of, just for clarity, right? I mean, this is the same thing, but let's just see what happens. Weird. I'm just going to solve whatever other problems, and then we'll go back to that one. Because it might be the same as some other problem. It's easier to think about. Call is to return values. Get next argument. Oh, I put remainder in the wrong place. Remainder was a return value from to integer, not get next argument. Undeclared identifier to integer, that's in string for to integer, which should probably move. Move. All right. So this is great. It should maybe work. So dash number 32, 129. Oh, we didn't increment our cursor correctly or something. Argument 4. Oh, no, that's our windowed true. Okay. There we go. 129. So it works, which is great. We got a couple things to do. You think it should be max info instead of max type of value. No, because, I mean, the thing is, these take types. Type infos and types are like different things. They're actually the same thing, but they're mildly different. I'm honestly not sure what's going on here. So let's try and fix this. Let's just say, in main, before we do anything, we're going to say value is an S32, which is 7. We're going to say t is type of value. We're going to say low is min of t. We're going to say print low is whatever low, right? And I guess that's going to be wrong somehow. Why? I just want to build. All right. Low is S32. Why is low equal to t? Am I getting some other? Oh, I'm not including math. Bro, okay, here's what's happening. This is error prone. We need to document this. So what's happening is we're getting the varargs version of min that's polymorphic and applies to anything and doesn't restrict itself to numeric types. Like, dude, you could pass a hash table to this. And if it was one argument, it would be fine because this for loop doesn't do anything for one argument. So we never try to do a less than. So we just return the input. So, warning, these overloads of max and min are error prone. You need to restrict them to numeric types and or rename max min in math to be max of type min of type. We really need to do that. Like, you know, I see overloading is good, but there's such a thing as overloading a little too much and being a little too confusing, right? So like a max or a min function that tells you the max value of a type should not have exactly the same name as the function that tells you the max of a set of values. You know what I mean? So the overload issue would be more of a compiler fix. No, I mean, in this case, if we just import math, I think we'll get the right one because this, we're only hitting this. I'm actually not sure. So overload resolution picks the function with like the best score, right? And well, we can get picky about which math. Let's do this. Let's say math is import math, right? Just to be, because we don't want most of math, because math is hard. Let's go shopping, right? But then here we could be very specific. We could say we want this one and that one. These will get renamed later. You know what I'm saying? Okay. There we go. Oh, we got to re-put this in. All right. Okay. So now if I try to say number 8 is 129. Oh. Okay, this is not good because we got a cast bounds check. Failed. Okay, hold on. So first of all, this part, this test down here is still giving us the S32, but let's fix that. Okay, so now it's actually the min of an S32. Great. So why are we cast bounds check failing? Like, we shouldn't be hitting that. Let's just print these. Shouldn't be hitting that. Isn't it great that we have cast bounds check failures, though? Isn't that the best thing in the universe? No, but it's pretty good. Oh, because value is S64. Oh, fudge. Okay. Right. We know what value is. What we want are the max and min of the thing in the type. Okay. Now I understand what somebody in chat was saying before. Yes, the type info tells us what we need. Not this. We know that's not the thing. I am making dumb mistakes. All right. But I think it's great. I should have listened. You're right. I don't see all the chat. It kind of scrolls by and whatever. But yes. So we want to do something better. So we get this size, right? So down here we have runtime size. And how do we want to do this? Like we can do the thing where we say if it's signed. Okay. I mean, we kind of just want to do this switch statement and range check in there. Right? So let's do some stuff. Okay, so let's say success is true. We're going to return success. We're going to say if range check value size, let's take this out. Range check signed of value size info, right? Oh, wait, we already have the size. You know what? For thinking about making a function that'll be more generally useful to people, like we're still going to print out these strings, which is a little. So here's the difficulty, right? Ideally, you would like to say just something like low and high are the range of this and have them be the right type at compile time. So this function would be polymorphic. The thing is, you don't know this value till runtime, so you can't do that, right? So you kind of have to break down the cases. And so I was about to make a function where we just say, well, just call a range check function and it fails. Okay, instead of saying too low, too high, we could just say is out of range, right? Whatever. It's not that great saying too low, too high. So let's say valid is range check value against info. This is going to be something that people could reuse, right? And if we're not valid, if your argument is invalid, as people say on the internet, then, well, see, the problem is we're going to have this signed versus unsigned thing, right? Incomplete. We're going to just do signed for now. Okay. I mean, like I almost, if we're going to do all this to range check it, we might as well just poke the frickin' value, right? Right? I mean, come on. In which case, we're just kicking the can down the road from what we were going to do anyway. I don't know, man. Okay. Range check and store goes value $T, I guess. Sure. Because I want to be able to call this with a signed or an unsigned integer. Although, see, maybe we'll just cast it. I'm of two minds about how to do this, but whatever. We're just going to do it. Okay, we're going to return success as a bool, low, high as 64. Right, so incomplete, handle unsigned. So we're just going to chop this out for now. To simplify our lives, we're going to put it down here. Okay. We're going to say what's the simplest thing to do? So for small sizes, you just shift by the number of bits, you know, -1 and whatever's. For 64, I mean, I guess that still works. Let's do this. Let's say, okay, hold on. Assert false. Isn't it funny how we were jamming along and then we just hit this one topic, this one subtopic of like dealing with all the different kinds of integers, and now we're in molasses, right? And that's just like, complexity does this. And it's funny because it actually is, when I was starting to do the language design, it was a little bit open to question about whether you should have signed and unsigned integers as separate types, or maybe you do something different, like all integers are typed just by size, and you say whether something is signed or unsigned based on the operation that you do. I decided not to do that, but that decision would have made things like this a little simpler because you only have to deal with half the number of cases, right? Anyway, okay, so we're going to say if info.signed, right, low high is unsigned integer range from size, whatever, big function name, of size, right? Or no, signed integer range. Okay. If value is less than low, return false. We forgot to, return if value is less than low or value is greater than high, right? Okay, otherwise we poke the value. Okay. So we need this. And we might just put that, oh, see, I kind of don't like this gratuitous use of metaprogramming for this, because you don't always, like this is even only useful for the case where you know the type at compile time, which we don't necessarily, although we could. Okay, here's the thing. We're going way down this road of saying, oh, we don't know this stuff, but we could actually, we do know this information at compile time. We're just not using it that way. We're going to not worry about it for now. We're going to keep doing it the way that we're doing it, which is to introspect on the struct at runtime. However, we could have just done all this stuff at compile time. Like you can't check the user input value against the range at compile time, but you could, you know, in that place where we iterated over the members here and did this. If we did this at compile time, we could generate like an ancillary struct that has the integer range or whatever, which you might want to do anyway, because if you're parsing notes, etc., whatever. We're just going to finish this way, and if it's smarter to do it at compile time later, we will do that. But we're about making progress right now. So so assigned integer range from size. Size is an int. Assert size is greater than is equal to 1 or size in bytes. You might think this is supposed to be 8, 16, 24, 32. That's forgivable. It's a common confusion that maybe we'll want to deal with at some point. Okay, size in bytes. Size in bytes. Whoops, size in bytes. Size in bytes. Okay, so low, or let's do high. High is going to be 1 left shifted by size in bytes minus 1, right? Minus 1. And the problem is that, okay, size in bytes times 8 minus 1, right? So that's the high value. So that'll be, right, if we have an 8-bit number, for example, this will be 1. This will then be 8. We go 1 left shift 7, which is the high bit, which is 128. We subtract 1, that's 127, right? And this should work for everything, because even if it's 8 bytes, we never shift that far. We shift by 63, all right? We forgot to return our values here. Success is a bool. Low is a S64. High is S64. Okay. So we're going to do high is that. Low is, well, low is just, isn't it not high? No, that is not correct. It is, it's just like, it's minus 1 in that number of bits. So it's really this. Really that. And the problem is this will overflow, or it won't. I mean, you get into platform specific shifting behavior if this is 8, which I think our shift operator is going to define a specific outcome on that, but we haven't done that yet. So low is not high and is also high plus 1. Wait, what? Oh, you're right. You're right. Now that this is overflow is intended here. I actually don't remember if we put in math bounds check. I don't think we have. Yeah. Okay, this only works, unfortunately, this only works if the number is the size. So we actually have to mask this, right? We have to go high plus 1. Actually, no, it's just, what am I doing? It's just this, right? That's all. Except that we have to use it, right? So high will be correct. Low, see, we're doing this comparison in S64. So this is the point where I've been programming for a couple hours on stream, so my IQ is like cut in half. But like, we want the number that is in 64 bits is all F's at the top, or all 1 bits at the top, and then stops at the high bit, and then is all zeros, right? So we want, we just want not high, right? That's what we want. Why did we return a success here? That was silly. Right? Is that, am I being dumb or is that fine? Someone else in chat says not high as well. Okay. So anyway, while we're doing this, let's just do the unsigned version as well. And it's really exactly the same. Actually, so we don't really need that comment. So high in this case is, so low is going to be 0, right? And high is going to be that, right? No, high is not that. High is not 0. Okay. So this is the problem, is we have to deal with this. So high is actually like that. For unsigned. And the problem is, you know, what happens if your size in bytes is 8, which again, we're going to define that to be the right thing eventually, but we don't have that yet. So we're just going to say if size in bytes is 8, high is equal to, right? Wait, is that, that's only 32 bits. Dude, 64-bit numbers are so big. Like, are you kidding me? This is how big computers are these days, right? Wait, 8, 16, oh no, that's 30, okay, never mind. See, this is what my brain is kind of fried. Okay, 8, 16, 32, 48, 64. Okay. That was 64. Yes. What happened to that Emacs burn-in on my monitor? It is still here. You cannot see this, but I see a vertical stripe. See right where my mouse is going up and down? I see a very faint vertical stripe. That, as soon as I do split screen, watch. I can predict with high accuracy where the line will be when I go split screen. Ready? It's where the mouse pointer is. Bam. I have magical prediction power back. Yeah, okay. All right. So this is great. You know what? Let's be less messy about here. Okay, we could bust out a secret feature maybe. I forget if it's implemented. Behavior due to platform-specific details. In the future, the outcome will be language defined in all cases. Because it's stupid to not have that, honestly. Okay. So there or there. Dude, whatever. Why are we thinking this hard about such a thing? All right. Redeclaration of high, redeclaration of low. Okay. Info is not a member of type info. That seems obvious. Oh, this is type info integer. Expression of type void is being used. Excuse me. Size is info dot runtime. What? Oh, assert. Okay, my assert parentheses are wrong. Ha ha. I mean, I guess you don't. I just like parenthesizing my sub-expressions. It's me. Okay. Number signedness mismatch. In 185, we are very strict about signs. In the minus operator, okay, this is a compiler bug because it should be able to use this as a U64 on the right, but it doesn't. Why doesn't it? It's supposed to know that this 1 is a constant. Something tells me that's not actually going to fix the problem. No. Left type S64. Wait. Okay, it's this part that's wrong. All right. Missing argument low. We are supposed to return. Look at all the mistakes we made. Isn't it great that we're in a statically type-checked programming language so we don't have to discover all these problems over the course of hours? Yes, it is great. So we return success, low, high. Okay. We're going to do that in here. I mean, so we're going to have to restructure this because to return the correct low and high, we actually need a different signed versus unsigned. Dude, I did the same problem there. Lol. That's what happens when you copy and paste. All right. Well, we have now completely broken our... Oh, I ran it without arguments. That's why. I was like, wait, we didn't get anything. Okay, value of argument number 8 is out of range. It must be between minus 128 and 127, and it isn't. 126. Oh my God. Minus 77. Minus 777. Oh, it's out of range. These are good. These are good. Can't you store low in S64 and high in U64? That is a good point. I mean, it's a little bit strange because you have to cast them one or the other way, but that's a good point. I mean, the question is just, does it have higher utility to have it broken up in this way? Not sure. I'm going to keep it this way, but it's an interesting point. All right, so we're going to handle unsigned as well. So if I go to, this is our, what's great is this is still our actual user program, right? All this complication is getting filed away, and this is just our user program. Let's go, let's call these signed, and we'll have unsigned. Okay, so now what happens if things are unsigned? Well, I think our integer parsing I think it'll just return us the big number as U60 or as S64, and we can cast it back, right? Okay. So if it's signed, right, else write integer as U64. All right. See all this complication that's signed and unsigned and all that happens. Let's combine this actually. So we're going to say if info.signed we just do this, else we just do this. Right? So we're just going to hide that cast to there. Going to get rid of it out of here and there. Okay. So this looks like the same code, but the thing is low and high are going to be different types down here than they are here. That's all. So should we make this polymorphic? Like, I could say value is a $t, low and high are t, right? And the thing is, it's not necessarily going to work if we make it polymorphic. Oh, maybe it will. Maybe it will. Let's see. I might not be thinking enough steps ahead in the 4D chess. You know what? We didn't ever use this success anyway. Okay. We're just going to assert t is equal to U64 or t is equal to S64, all right? So we're going to say, instead of checking info.signed, what happened to my size? Did I delete the size assignment? Size is info.runtime size. All right, so we're going to say if t is equal to U64, we do one thing, else we do the other thing. Signed integer range from size. And we poke these. And you know what? I bet that this all simplifies and boils down. Okay, here's the thing. Here's the thing, dude. If we know that it's within the range, can't we just poke it as either signed or unsigned and we don't care? Is that true? Because this cast just truncates down, right? Like, I'm pretty sure, can't we just do this? I think so. Won't that break things because value is declared as S64 in the function header? In what function header? We don't have function headers. What do you mean? I guess I don't understand. Okay. So if t is U64, then we do unsigned integer range from size. Otherwise, we do signed integer range from size. I need to learn enough eLisp again, or tolerate enough eLisp to go make it understand this indentation, because it drives me bananas. Okay. Oh, dang it. All right. See, the problem is we don't have access to low and high down here because it's different types in here. So here's what we're going to do. We're going to say there. We're going to say store pointer value size, right? I hope this doesn't break. We're venturing into the realm where it's possible. Now watch Emacs ruin the indentation that I just did. I'm going to give up on that. All right. So we're sort of farming out the part that's the same so that we can return the return values. How many mistakes did we make? Redecoration of size. Wait, what? Oh, I did it right there. I was like, did I delete that? No, I didn't delete it. All right. Argument 4, number 8. Oh, because we renamed it to signed 8. Oh, right. And it's minus 7077, not dash 777, right? But whatever. Signed 8 is out of range, but signed 16 could be minus 777. There we go. All right. How about unsigned 16? Out of range, it must be between 0 and 65535, right? And we don't set it. But if we make it, well, 69105 is too big as well. Must be between 0 and 0, value of argument is out of range. But if it's 60,001, then it shows up in the argument. How cool is that? Won't your language built-in typecasting range checks break with the common switch? No. Well, okay. What would break is, I guess, this autocast here. I guess. Yeah, it might break. So I'm hoping I put in a directive for that. Like it should be, we don't have no cast bounds check, I guess. We only have no array bounds check. Oh wait, we have a cast flag for no bounds check. Cast no bounds, right? How do we activate that? Oh, dude. I was nice when I did this. So you can put no, I don't know if that works on AutoCast. Let's see. All right, great. So that just says this cast is intended to potentially numerically over underflow or whatever, and just don't care. Commas confirmed. Did I not demo this? I guess I didn't demo this. Commas confirmed. There's not that many commas yet, but. Okay, we're doing pretty well, I would say. I don't like how much complexity has gone into this integer thing. And I think in the future we will try to simplify it. But it does the job for now. You know, we're at 200 and something lines, which isn't that bad. I mean, 268 lines is, well, if industry average is 10 lines per day and there's 21 work days in a month, then we've done over a month of work. It's for industry average programmers. Okay. Well, that's, you know, that's counting blank lines and stuff. So it's not quite a month, probably. Would a simple if case for every type have worked? Was kind of confused about the byte size. It's a good point. So do you mean could I have done this? Instead of testing the size, I could have said if t is equal to, and said case U8, case U16. And the answer is yes. That would work. The question is that better? Maybe. Like you wouldn't need this argument, right? This size argument would be redundant. Oh, except no, because value, actually no, because t here is not the target value size. Right, t is the size of the source value. So without this, we don't have that information. So actually, no. Is that statistic from when that book came out in 1975? Yes, it was in Mythical Man Month, but it's also been in a few things since then. I'm going to heat up some more tea water. Are there any further questions about what we are doing right now? The next thing that we would do is go back. Hold on. So we did that. We didn't do these. We probably won't do all of these tonight, honestly. But we've done these. Like we could test these more thoroughly or whatever. But for now, for our like not trying to be super awesome thing, we're just going to keep a couple of these, right? Just so we could test it. We'll do floats next. And then maybe we'll do arrays if we're not too tired, or maybe it'll be Call of Duty night. So any questions about this while I heat up some more tea for myself? We're going to do Bengal spice because we've just done 2 Earl Greys and it's a lot of caffeine. So we're going to Bengal. Questions? Seriously questions. Will this parser support unnamed arguments, e.g. file names, without having to say -file x? It's a good question. We probably should do that. That's a very common thing. What should we do? We could either return an array of unnamed arguments as an additional return value, or we could put them in the arguments struct somewhere. I'm leading toward the latter. I know you've worked on compilers in the past. What perspective did I gain this time around that is most impactful for my everyday work? It's really about the difference between my earlier languages that I worked on and now is that now I have a very solid idea of what the problems are that I would like a programming language to solve. Whereas in the past, design was like, wouldn't it be cool if a language did this or that? And those are very different mindsets. Very different mindsets. Could I tell us what exactly the autocast commas do? So commas like that are just options on operations. And the comma no check just says don't do cast boundary checks, even if those are enabled as a global compilation option, right? So don't, as a debug feature, if you cast a number to another number and you don't do that, then a cast bound check may assert and potentially stop your program, right? Which is good if you're trying to make a robust program that's in debug build, potentially, right? You can also make it not stop, right? It doesn't have to stop, but it would output an error. In release build, you generally turn those off, right? And so what we're saying is, even in debug build, like we kind of intend, or we definitely intend to violate cast boundaries in those casts. So don't tell us about that, right? Try writing 10 lines of code when you're sitting in meetings all day. I know, dude. That's why I don't like jobs with lots of meetings. Okay, so let's put unnamed arguments. How would you put them in a struct? Well, you might have something like, you know, whatever is an array of string with a note on it that says unnamed args go here, right? Or whatever. And then you could even have this be like integers or whatever, and they'd get parsed into integer. It just, you know, that's a little fancy. And I feel like it's maybe better to just return them. What if different modules built into the program expect their own sets of arguments? Maybe have an option to suppress unrecognized argument errors. Yeah, I buy that. The thing is, you also, like, that is not something I'd want to program without a specific test case, because the thing is, you also want to remove the arguments that have been handled, because you don't want another module to like think it should be looking at this module's arguments or whatever, right? So there's that. Also, there's the question of, do you do it in series like that? Do you do one module and call another module or whatever? Or do you up front like make like this function could, oh, I guess it can't really be varargs because polymorphism doesn't work that way. Anyway, I don't know, but yeah, something like that we should be able to do. It's just I don't want to do that speculatively, because that's the kind of thing where if you don't have a very concrete use case, you'll do something that's kind of wrong or kind of not really what people want, right? So I prefer to be like, you know, could the integer handling part be simplified by using a polymorphic function? We do use a polymorphic function, right? These are not polymorphic, but this is, that was the whole thing that we did here. So this, you could pass it with either U64 or S64, and it'll do the thing. This is not really the most elegant way to do it. I feel like you could cut this amount of code by half. It's just not occurring to me right now what it is. I bet there's a trick that's real good that'll cut this down. Can any type be parsed into any other type? In principle, I mean, so that's the thing, is realistically, what we should provide people is a thing that parses a string into any supported type up to a limit, right? I mean, I don't know. But certainly all the primitive types, there should just be string to type. And, you know, maybe this will end up being that later. Like maybe this stuff will get factored into that, but we don't have that yet. Do quoted multi-word arguments need any special handling, or is that handled by the shell? Those are a pain in the butt. I think the answer is probably different between Linux and Windows. So I don't even remember here. I think I would put that on incomplete, like incomplete robustly handle quoted arguments on Windows, Linux. Vague remembrance is Windows is really crappy about this, and you probably have to reconstruct quoted things yourself. Like they probably come in as separate arguments, whereas on Linux, the shell probably parses it as a contained string and sends it to your program, right? It's just, we have to make sure, we want to make sure the same thing happens on both operating systems. Is polymorphism going to be coupled to types? I don't understand the question. Can you ask that question more specifically? I don't know. What are examples of the two different mindsets? Detecting if the user code is a mess and letting it be known would correspond to, it would be cool if, yeah, sort of. I mean, it's just like libraries that are written by people who didn't need to build it for a specific purpose and didn't need to use it tend to not be very good libraries. That's just almost completely universal fact about programming, you know? And so anytime that I start programming things and we start getting into speculative use cases, I would rather wait until we need that, or you know, maybe we go into beta and somebody starts using the language and starts using this argument parser and says, oh, this is cool. However, I totally want to do this other thing. And then we would look at what they want to do, how they want to do it, what would work well for that case, and then see if there's a commonality between what they want to do and what other people want to do, and sort of work it out that way, rather than put work into doing something random that may not be right. You know, that's the open source way to do it, and I don't like it. I think it results in useless things a lot of the time. Array to bool, yeah, arrays evaluate as false if they're empty and true if they are not empty. Yeah. Okay, let's do some more stuff. Let's do floats. Floats, I think we can get away with just parsing a float 64 always and then casting it down. And if that's not pedantic or for someone, then they can bite me for now and we can deal later. So we have string to float, which is in, let's see, so Ignacio made this reflection. What's in here? Array, string counts, value. Oh, dude, he actually has a lot of this. So wait, set value from string. It's not really doing range checking though. So he's basically got kind of what we're doing, but like less bulletproofed. Interesting. So we may want to combine these at some point later. Depending, I would have to look at the use cases of this code and whatever. Okay. String to float is, well, we have a string to float 64 and string to float. All right. So string to float 64. So we kind of have a 64 and a 32-bit just pasted from each other, I guess. And the question is, do we want to parse them separately? Oh, we actually do just downcast it right now anyway. So a more robust version might not do that. But we're just going to do this. So if it's a float, we're gonna say if info.runtime size is 4, else assert info.runtime size is equal to 8. If that's not true, we have a data corruption. It really needs to be 4 or 8, because those are the only kinds of floats supported by the language. So this is float, 64, cast float value. Okay, so this is going to be a lot shorter than the integer code because we're being a little bit imprecise in this downcast here. So we're going to say, well, we're going to do this. Actually, let's flatten this out a little bit. I don't like really deep control hierarchies. So like, we're just going to break from this loop. Oh, dude. We don't break from the loop. So we're redundantly checking. Even after we found the correct struct member, we keep going. Once we have found the proper struct member, stop. Okay. So, well, float, we'll just call it value. Float success remainder is string to float, string value, right? And if not float success, it was not a float, it was whatever. Else, we'll put some nesting there, right? Okay. So where do we get the string from? Well, that's going to be this. And I think that's it. Of course, we probably made a mistake, but nope, maybe not. Okay, so that's without the float parse. Oh, unsigned 16 isn't a thing. Unsigned 8 of 111. Bam, so that's there. So now, let's take out our whatever. That was funny. Okay, let's take out our low is whatever. We don't need that anymore. That was just a thing. Oh my God, we just deleted half a day of industry standard work. Okay, so we have English, we have windowed, we have 111. Now let's say X is 5, Y is minus 69105, 1, 2, 3, 4. Ooh, we asserted at line 105. Really? Oh, because info is the wrong thing. What is info? It's the type info of the struct type holding all the arguments. I just used the wrong variable. Okay. Okay. There we go. Boom. I guess Y is the float 32. Let's make that X and Y. I don't think we're getting enough precision in our float parsing right now. Wait, are those both? Wait, what? My arguments. Well, I'm just going to put investigate float parsing accuracy. The thing is, we don't have our final float parser right now. Like if you go to here, this is using A to F, which I think is probably, we actually want A to D, right? Is that right? Did we even use A to D? Wait, is that, I don't remember these functions. Let me see. C, A to F. Tutorials point, double A to F. Okay, so we're just getting a crappy thing. So I'm not going to worry about that right now. We're calling out to C right now. This is one of our few remaining C language dependencies. We want to get rid of this and have our own code for parsing floats, which we have. Somebody donated to us. We just haven't deployed it yet. We don't want to call out to C unless we absolutely have to, because we want to avoid any dependencies on the C library if we don't need them. So for right now, we're just calling A to F, and it's just being crappy and not returning us a good enough thing. Is it the conversion or the print? I think it's the conversion, but let's see. Like if we go back to here and we say, we go into main and we just say value, I shouldn't need to say float 64, but whatever, 69, what was it? Minus 69105.1234. So we should hopefully do that. Value is whatever value, right? So yeah, so we print it fine. So it definitely is the Windows A to F is not doing the right thing. I'm using string to float in the part. Oh, right. Okay, never mind. I got confused. You are correct. String to float 64. I was about to blame libc. It should be this. Yes. Thank you. Okay, well now I think X is actually the float 32, right? Let's see. Yeah, X is the float 32. So we go back to the version where that was Y and that was X. Okay, there we go. We actually can kind of program. So now we kind of want to do arrays. Let's do a pre-screen for arrays. And I'm not going to do enum tonight because enum, again, I don't have a test case for it. And I don't want tonight's stream to go on forever. So I think, at the beginning of the stream, we mentioned SOA. I think we'll do SOA a different time just so we could be mentally fresh and sit down and do it. But I think that'll be another fun thing. So this one isn't that metaprogramming. It's just some regular polymorphism and then type information. But next time, the SOA one will be a lot more. Actually, we might. We might do some harder core thing. Let's see. Are we going to upload it to YouTube? Yeah, I think this has been successful enough that we upload this for sure. Let's do, we were going to skip constant, right? Let's do that. That's probably easy. Let's just get a little bit off our giant incomplete thing. And then we'll do arrays. So struct member. So if it's constant, or imported, we don't want it. So if member.flags and member.flags constant or member.flags.imported, continue, ignore this. All right, so okay, so now we already know that a string of the wrong kind will kill us. Oh, we can't, a relative string you can't assign to a constant because it's in a different like address space. Well, let's just put, I mean, for now, this might not be the best error message, but we'll put Cowabunga is a constant 37, right? We could even say the type, U64. All right, so we're going to compile that. We could do an unsigned string compare. Right now, we have to say, and it should say like not found, because what happened is we skipped over it when we made our members, right? Yeah, it's not valid. Boom. So that's fine. You can convert this to compile time. Yeah, I mean, dude, I gave a speech today, and now we're doing at least 3 hours so far of stream. At some point, I just start feeling like, oh, it's enough work for today. Or enough of this kind of work, you know. We might have to put some work in Call of Duty. That's what I'm saying. All right, if there's an array. So first, we're going to pre-screen arrays for fixed size. We could, in theory, handle variable sized arrays, but I don't really know what to do with those right now. So we're just going to disqualify them for now. So if it's an array, then we're going to go TIA is cast to type info array member.type, right? If TIA.array count is less than 0, well, is equal to -1, right? Then we say report error member whatever. And again, this is something we could statically forbid as well. Remember, whatever is of undetermined size. This is not yet handled. An argument parsing if it will ever be. Because I don't quite know what that means. Okay. So we could test that. Well, Cowabunga is not valid, so we take that out. So now my arguments, we're going to say, what if size is this? We should reject that. Oh, we got to recompile. Got to recompile. Okay. Oh. Sorry. All right. Member size is of undetermined size. This is not yet handled in argument parsing if it will ever be, right? If I do this kind of array, it also should say that. Yep. But if I go this, it should be okay. And it is. So that's great. However, if we try to use it, argument size is of unsupported type array. So now we have to start doing some things. So down here, string, integer, bool, float, array, we do something. I don't know. So now we want to be able to do arrays of these things. All right? And so we're going to probably want to be recursive. Let's put this through down here for now. We're not done. It's time, I think, to factor this into one function. Right? We could do that here. We could say success or member success is handle one argument. That sounds a little bit like get next argument, but whatever. Handle one argument of args, of cursor, of in member.type. I think that's probably enough. If not, member success. What are we doing? We're just going to break. We actually don't break. We should break if argument parsing fails, because otherwise you just spam people with errors. Success is false, break. Okay, so for now, we're probably going to move this somewhere else for readability, but for now, we're just going to put this in the same scope. Emacs is going to hose us for indentation no matter what, so whatever. Handle one argument is args is an array of string. Cursor is a pointer, or cursor pointer is a pointer to int. Type is a pointer to type info. Let's call that info. Okay. So we're just putting all that in there. Actually, like, we break no matter what. Like, once we found the name, we break. So eventually we're going to delete this out of here, and we'll have a relatively understandable loop again here. But for now, I'm just going to leave it in the same scope, because if we forget an argument, then it's easy to type while it's right here, you know. So this is info.type. Dude, Emacs hosed our indentation. I need to fix this. Not tonight. But yeah. Well, we probably screwed some things up. Arg. Let's call that name. Just because it's no longer, we're pretty far from it being the arg at this point, right? So we're just going to say that, something like that. Oh, cursor pointer, right. And success. Okay, so we're going to want, we forgot to return bool, success is true. You know what? Let's just, no. I was going to defer return success, but that's obnoxious. All right. Okay, slots. I forgot to pass slot. We'll put that first. Whoa! Buddy, LLVM backend didn't like that. Neither did x64 backend. We found a compiler bug, people. I don't think I want to fix it tonight, but okay. So something that we're doing, you know, I think what's going on is the fact that we put this function after this break has confused the compiler. So we're just going to move it out like we were going to anyway and hope that that fixes our problem. And then we'll note that there's a compiler bug otherwise. Okay. Oh, because we're not using this, which was fine when we were inside that scope. Can only break from within a loop. All right. Okay, so let's say compiler bug. We used to have handle one argument here, but it tripped a bug in the scope tracking stuff. All right. See, this is why we haven't done a public release of the compiler yet. People ask me, why haven't you done that? And the answer is, because that, bro. Well, no, that's not really. There are many dimensions to the answer. Okay. But we will, like I said, private beta before the end of the year. All right. Dude, we're at 304 lines. So many lines. So the reason let's just make sure that that runs and we get our values. We have our values. That's great. The thing we don't have is size. And then why do we say argument 11 does not start? I thought we would have broke. Like we should be returning false from handle one arguments. Oh, so out here, we should break so that we don't keep cranking through the argument list. All right. So there we just do the first argument, or the first error, and then we stop. Okay. So we have an array. And now the question is, can we do some cheese? So here we go, and we're going to say count is this. We're going to assert count is greater than or equal to 0 because we checked for this when making the members array. All right. For 0 to count minus 1, we do something. We say new slot is slot plus element size, which we don't know yet, times I. Let's call this I. Right? We're going to do new slot, and then we're going to say handle one argument new slot args name. We're going to have to, like, our error reporting might get a little bit confused because our errors so far don't have the concept that we might be halfway through the arguments supplied by name or whatever, right? So we'll have to test that. Name, cursor pointer, and element type. Let's just go element type dot runtime size in bytes. Is that what it's called? It's just runtime size. All right. Sometimes I get really pedantic about names and other times I don't. So what's element type? Element type, I think it's just this, right? Or is it called array element type? Element type. So there we go. How many mistakes did we make? 0. I mean, it claims to have worked. So now the thing is, our print statement doesn't print arrays right now. That's something that we could deal with later. But here we can check that, right? So we're going to say print sizes, right? And then for size print whatever, comma it, and then new line, right? Like that. Whoops. For args dot size. How good is that? What happens if you only passed one? Well, that's the part where we'll probably get a misleading error message, and we may want to provide more context. So like if we just do size 3, missing the value for argument size, right? So that's a little bit, it's like, right, we maybe want a better message. But this is pretty good. This does, I mean, we'll fix that in a second, but I'm just basking in like, hey, man, I think we could now convert the Sokoban argument parser to use this. And it'll be more robust than the old one in terms of things. Oh, we can't quite yet because we don't have the thing about were certain members supplied. Okay, let's fix this. And how do we do that with the least? I could make some global variables. That would make this not thread safe, which I don't want to do. So I could have like a parsing state that I pass around, right? Parsing state is a struct of, oh, by the way, okay, let's be stupid before we do this. Just to illustrate the power of thinking with portals, right? This is going to be an array of 2 of an array of 2 of an array of 1 S64, right? Our print statement is going to just print arrays or whatever, but let's at least make sure that compiles, right? Okay. So now if we do this, that's not enough, right? So 3, 4, 9, 37. There we go. So that's pretty good. The thing that won't happen, if we put an array of like some struct here, we don't handle that, and it's unclear that we want to. But you could put an array of, so let's say message is an array of 3 string, right? So let's test that. right? Let's recompile the thing. So that's with size 3.4. And our message is going to be hello sailor exclamation point. But if you forget the exclamation, if you're not enthusiastic enough about saying hello sailor, it'll get angry. Right? Why does size have 3 array declarations? Because I wanted to do that to show that it worked. What do you think? What do you think we're doing here in this channel? All right. That's all good. It's all good. So okay, let's do this parsing state. We're going to say, we're going to cut down the number of arguments that we have to pass and stuff. We're going to do all this. So we're going to say args is an array of string. We're going to go name is a string. This is like the outer argument that we're passing that may have subparts. We're going to have cursor. We're going to have to change back our cursor pointer, but it's fine. Cursor is an int. And then what else do we want? We want inside array, which is false, and current array index is 0, right? And this is really the reason why we're introducing this. And we don't, like at some point, we just have a bananas amount of parameters, right? So anyway, here, we're going to go, here's our loop again where we do handle one argument. And we're going to say state is a parsing state, right? State dot name is arg. State dot, well, state dot args is args, right? State dot name is arg. State dot cursor is cursor. And then the rest of it we'll leave at default values, right? And then when we handle one argument, we're going to pass, do we pass state or do we pass the address? I think we just pass state, because if we enter an array, we're going to make a copy of this state. Yeah. Except that we need to copy the cursor back when we do that. Oh, right. We need to copy it back here as well. Oh, yeah. No, we need to make this mutable for now. We could have passed cursor as a separate thing, or okay. Here's what we could do. Instead of that, we can have this state just be a thing out here where the args is set and the cursor is going to be 1, right? And we delete this. And then when we get down here, we set that to be the name. So some of these members of state are going to mutate for every term. And sure, okay. So we're going to do that. We're going to handle one argument. So state is a parsing state. And then all this cursor pointer stuff. So we're going to get next argument state. Also, this success value, I mean, frankly, we could collapse that into the state as well. We're not going to worry about it yet because it's a little bit different, but yeah, we could. Get next argument, state, and handle one argument. New slot, state. Okay, but here's the thing. Here, we are going to say, we're going to say old state is whatever state was. And the only reason we're doing that is we're going to go here and say oh, you know, should we, what about the success? Okay, so arg success is this. Just because we're doing this, I'd rather, because of things like this, I'd rather have the state, the success just be on the state maybe, but we're not going to think that hard about it. So at the end here, we're going to say restore the states array variables. Note that we might have already been inside an array. It's multi-dimensional, so don't just set it to false, right? So we're going to say state dot inside array is old state dot inside array state dot current array index is old state dot current array index, right? So that's just for the case of a multi-dimensional array. Yeah. Now the reason we're doing that is we're going to say state dot inside array is true. State dot current array index equals I. Can you smell what the rock is cooking? Okay, so handle one argument, or no, get next argument, right? Get next argument takes a state. State, parsing state. Do a pointer to parsing state. And again, like that success probably should be, we're going to put a note at the top. Incomplete. Oh, we have handle arrays. Fold success variables into parsing state question mark. All right. So get next argument. Like what? It's weird. Like we're returning success, but we're also setting success. Like how did we end up doing that? All right. The whole reason we're doing this is because down here, yeah. Why don't I just do this? Okay. So we're not going to try to fix this message yet. We're just going to try to get this to compile. Like guaranteed, there's still lots of mess ups. So like cursor pointer, where's that stuff? Because we didn't fix that at all. So this is state.cursor. Okay. Line 73. line 90. We got to pass a pointer to state. Undeclared identifier name. That should be state.name, right? That should be state.name. See, this is the other thing. Like at some point, when we call report error, we probably should just pass state to that so it could do this count state name and whatever. Again, that's a thing that we could think about maybe later. We could just make a local variable called name, honestly. And this is args. This is state.name. You know what? Let's do a using here. Let's be all like C++ and pretend this is an object. So we're using state, and we're going to get rid of the state dot. Okay, that appears to have worked. But what happens if we're not enthusiastic enough when greeting the sailor? Well, missing the value for argument message, because we haven't actually changed that yet. Okay, so here's what we're going to do. We're going to say if state, what do we call it, inside array? If state.inside array, we say one thing, else missing the value for argument, whatever. What do we say? We say report error, not enough values for argument, whatever. Only got whatever, but we need whatever. We don't have the information, so we're going to have to add that to state of how many we need. So this is going to be name state dot current array index. Actually, like if we get 0 items, then just saying missing the value is fine because you're like missing the whole thing, right? But if you're in the middle of the array, then we say state.currentArray index, state.array indices needed. All right. So well, array indices needed is 0. So current array, so state.array indices needed is count. And down here, we will reset that to old state. Right, right. So not enough values for argument message, only got 2, but we need 3, right? But if we put it there, then we're satisfied. Now what happens if we take out, well, if we take out that, we should fail to parse message, right? Whoa, why did we say argument procedure blah, blah, blah? I guess name is a function. Wait, value of argument, we screwed something up. Count, yeah, this is state dot. This is the problem is we have a procedure called count and print. See, that's overloading for you, man. I kind of don't know if we should have a procedure called count, honestly. But whatever. Wait. Sorry, state.count. What do I mean there? Wait, what the hell was count? That's the cursor. That was wrong the whole time, because we never had a count that meant that. We just didn't know. Wait, what? It was not an integer. Wait, what just happened? Dude, I be tripping. All right. Argument 12. Yeah. Now, if that's, however, the end of the input, we don't have an argument 12. And now we get the right message. If we don't even have that, uh-oh. Why do we think we got 1? Oh, I mean, I think we're not, okay. Huh. We do set needed no matter what. Oh, but we don't set, okay. No, we do. Why do we say only got 1? Are we somehow why? Think I missed a cursor increment. Is cursor also a procedure? Dude, I don't know. Maybe. Oh, wait, we were doing a using, right? Not in that one. I don't know. We'll have to investigate. Like, I don't think we should have procedures in common libraries for things. Like in a language with overloading, I mean, yeah, type checking happens a lot, but something like a print that takes any type, it's a little bit of an error-prone thing to do. So I think we're going to want to audit that. But anyway, I'm trying to figure out, so one of two things could be happening. Either we somehow have a little string craplet at the end, or for some reason, current array index is not 0, but it looks like it really should be. Like we set it to 0. Let me just print here. Right? Just dumb ass printf debugging, right? So doing element 0, missing the, oh, I didn't see that it's printing both. So like we're just not exiting, right? We're not just breaking from this loop. That's all. That's all that's happening. Very simple. Okay. Honestly, this is pretty cool. Whoops. Let me go to the version that worked. There we go. This is pretty cool that we could do this. I mean, we did it all in one session. It's been about 3 hours and change. You know, we haven't put in all the capabilities that we want eventually. I think we're going to do, maybe next time we'll start off with some of these in part 2. We'll do detect multiples of the same argument. We'll do generate information for which arguments were actually supplied. And probably this and maybe that. Maybe those top 4 we'll do in a subsequent stream. I mean, those are easy by themselves, but then maybe we'll bridge into doing the SOA thing, because this, I'm leaning toward doing this with a struct generation, which would be fun. And yeah, it's just, we've been going 3.5 hours and we've got a pretty cool thing. So we'll call this success. So again, the whole point of this for people who tuned in later is so that you could do something really simple in your user program. Like just say, here's the command line arguments for my program. And then you just call parse arguments and the type information gets looked at and parsed and whatever. So we're not doing sophisticated advanced features like you might want to have aliases or, you know, tie things together or whatever. We'll maybe start getting into that next time as well. But this has been fun. It's been a cool, like, we started with nothing. We now have this capability. It handles strings, integers of all types, floats, and booleans, and arrays of any of those. Eventually, you could imagine handling structs so that you could say things like, you know, foo or args dash, I don't know, graphics dot vsync false, right, dash graphics dot poof shader, right, etc. So that you could have subcategories of things. That might be a thing that we do. I don't know, maybe not. Write integer as S64 also handles U64. We could do that right now. Let's just call it write integer. This is probably going to be private to us, so that's a good point though. Write integer. All right, did we break it? Probably not. That's pretty cool, man. What do I think about implicit enum names? We want to do that dot operator, but it would not be just for enums. It would be for anything like, you know, like struct members or anything. It would be an implicit scoping operator. It's just, it's down the list because it's not totally simple and there's other things that are more important, but I find myself wanting to do that a lot. Seems like having structs like that is just more typing versus having a separate arg for each. Possibly. Yeah, I didn't say it was a good idea. I just said we could do it. Have you considered hooking a debugger into the bytecode so people can inspect their compile time functions metaprogram? I mean, we basically would have to write our own debugger at that point. So who knows? I mean, so the thing is, right now, you can't very effectively debug your compile time metaprogram except with printf debugging. So we do want debugging capability, but there might be other ways to do it. Like if instead of interpreting bytecode, if instead we compiled it to native machine code in a DLL and then ran that, you could like break in the DLL with your regular debugger and it would run faster, right? So there's the question of what's the better way to handle it. The good thing about, I don't know, there's potential complexities. Any word on Handmade Seattle? I do not know. I don't currently have tickets because I'm a little tired of traveling right now, but we'll see. We'll see. How much slower does the bytecode make it overall? Currently, I don't know. I would say substantially, but I don't know what that means in terms of numbers. Yeah, I wouldn't want to ship a game that runs at compile time. So right now, we kind of, like if you look at profiles of the compiler, um, the compile time bytecode sometimes really takes up a substantial amount of time. However, it gets masked because it happens in parallel with the compilation of the program, right? Like the main compiler loop hands through like a thread safe locking mechanism, hands messages about your code to your thing, and then your thing can think about that stuff, but it's in parallel with the main compilation. So even if it's a little slow, it doesn't matter that much. But I would like maybe to do the equivalent of like a JIT or whatever. I don't like the phrase JIT because it has some connotations that I don't like, but to essentially do that, like instead of interpreting, just like make some machine code out of it. Even if it's not smart machine code, like our x64 backend's debug build, is not smart at all right now, but it still would be a lot faster than bytecode, I think. Do I have a job in the industry or do I freelance? I am self-employed in the industry. Wait, doesn't when people say the industry, don't they mean porn? I don't have a job in the industry. In the industry. I have a job in an industry. Have I started going over the applications for the position we tweeted about? No, mainly because I gave this speech today and was doing all that stuff. So I think tomorrow we start going through those. Anyway, thank you everybody for coming by. Is a speech available somewhere? Nope, but we will do a public version of it later. This was at a private event today. All right, let's find someone to raid. Devin knows that we're doing this, so we have to skip him if he fired up his stream just for this. We haven't done like a programming raid in a long time. So let's see what we come up with. You're working on super secret stuff. Oh, that's good. All right. Metaprogramming, we could raid that. Watch repair. It's a little off topic for us, but it's cool that that dude has a lot of people. I am on the line, are you? I don't know what that means. Telescope control. It seems like more people are doing interesting stuff today than usual, so that's cool. Unreal Engine C++ and chatting in Spanish. I guess in English. He says English as well. We hosted this guy before, didn't we? Bitcoin exchange. I'm not really seeing a lot of programming. Oh, 2D roguelike. I don't know. What do people see that is really appealing? Is there anything that you're like, yeah, that's the programming I want to see? You could do building an MMO. Wait, is Squirrel up? Wait, or is a Squirrel? Do you mean Squirrel, the game developer? Why is it the year 2020? Okay, I just see the word squirrel in a title. I thought you meant squirrel, mildly famous game developer was doing things. All right, let's do maybe this one. Thank you, everybody, for coming by. And we will continue soon with this same functionality.